Recording is on.
Oh, I'm glad that didn't get called over.
Yeah. All right. I don't even see his. I guess he was here and then he left. Is that what
No,
happened?
he just texted me. He's going to be here in a minute.
Okay. All right. Well, these weeks go by fast.
They do.
I guess these fortnights, I should say, go by fast because, yeah, here we are again. So, good evening, everyone. I hope that I stay awake. I don't know. I was working outside most of the day, so I'm dragging my butt a little bit right now, but I am here. So, part of what I was trying to accomplish over the last couple of days, and I was trying to get it in time for the Carrick's CQ QSO or CW QSO on Monday was drilling a hole through the wall of the barn to get the shack indoors for the winter because I want to leave the antennas that I set up back in June for field day where they are. So unfortunately, I discovered I did not have a drill bit long enough to do the job. So I don't want to make too much of a mess of my partner's barn. So, you know, I figured I need to do this properly, so I'm gonna have to wait until I get my hands on a few 12-inch or 15-inch drill bits or whatever I need. So anyway, so December, I hope to be dying away with the folks from Kingston. So
Well, that'll be good.
yeah. All right, so let us get started here. We are definitely past our start time, so we have a couple things that are on the schedule for tonight. Peter, you've got, I think, part 2 of some interesting stuff to talk to us about, and I believe, Kevin, you had some test equipment discussion that you'd like to...
Observations, yes. That's
Observations, yeah. All right. So I'm not sure exactly how much time you guys are going to need, but hey, you know what? It always seems to work out. So whatever you need, you can take. That's the only, things that are scheduled for the agenda. There's those two, unless anyone has anything else. Sorry?
I pared it down to an hour and a half.
An hour and a half. Awesome. That's good. What was the original?
2 1/4.
2 1/4. All right, very good. Well, maybe I'll let Kevin go first so you can chop it down to 20 minutes. Give you a little more editing time. But
yeah, I guarantee mine is not an hour and a half.
An hour and a half? Okay.
Or not even half an hour. But anyway, right. Just a few. I'm big on the short stuff. I like short meetings, short presentations, little bite-sized chunks.
All right. I've also put Dave on the agenda as well for tonight, even though he didn't, because he's been chirping a lot about 3D printers, laser attachments for etching PCBs and all that. So I'm going to make him talk for a little bit once he finishes. Once his mouth pie hole is oh look, it's clear. Look at that.
Oh look. Look who shows up.
Yeah, well, at least one orifice that doesn't have much in it. So, all right. Anyway, I don't think there's too much in terms of housekeeping to talk about. To my knowledge, there's really no events coming up of note to us as a community. So, I think we could just, unless anyone has anything that I have missed in the upcoming month or two, there's not really a lot that happens in November or December, I suppose.
Yeah, I have something.
Yeah.
Just as a quickie, Al Wilkie's doing his web thing with is it all electronic? I forget the website right now with the using your oscilloscope and stuff like that. His webinar. That's tomorrow. I did a post on it there about right after our last meeting. So that's going on tomorrow.
Right. Daytime, I presume, right?
Yeah, off the top of my head, I'm going to say 1 o'clock in the afternoon or something like that.
Okay. Well, yeah, so I guess that's posted on the homebrewgroups.io.
Yeah, faculty messages now.
Yeah. Okay. All right. So, I suppose, Peter, you put your hat in the ring first. So if you'd like to start off.
Okay. Not visible?
Yep, that's good.
Okay, some interesting stuff to me. Don't know if you guys find any of this stuff interesting, but we shall see. So I came across this flying microchips, and you can kind of see in the upper right there the size of these things compared to an ant. And they based the shape on this. I never heard of this before. I probably can't even pronounce it. Tristatella tiaea. I don't know. Plant star-shaped seeds, so it kind of propels itself around a little bit in the air when they drop it. The idea being is they're doing some sensors and that kind of thing, and the main one with this article was for environmental monitoring, and they're supposed to be biodegradable. I guess if I had talked about this about 3.5 weeks ago, I'd remember a little bit more details about how biodegradable it is. But anyway, you can see the size of it, and on the left you can see it on the guy's fingertip and whatnot. So apparently they'll drop these out of an airplane or a helicopter, I guess, and into the air, into some remote spot, and then they just go fluttering all over the place. So they drop them by the hundreds or the thousands, I guess. Came across this STEM32 cube monitor. There were some. We've been chatting a little bit of late about maybe switching from the Arduino over to a STEM32 for doing some things, and of course came across this. And I thought, oh, this is familiar. And I thought, Dave had something going on with this, and sure enough, like on my third bullet point there, Node-RED, and I guess Node-RED has the same kind of thing, but this one here is earmarked for the STEM32 processor. So there may be something to play with this if we ever do get going with the STEM32. I do have one or two of those boards around. I guess I should try and figure out something to do with them. Another thing I came across, and I forgot about these guys, Texas Instruments, they have these training videos and whatnot. So I went over there and had a look, and they got quite some interesting ones. So sometime this winter, if you're getting bored and looking for to do something on Sunday afternoon, maybe check out Texas Instruments training videos. They got some good stuff there. These I thought were really cool, and I thought, wow, they would look really nice in a project. You form them around, they stay in place, they don't peel back on you or anything like that. And then I saw what the price was, so that kind of took these cable assemblies out of the equation. $150. Wow. Even if they do what they're supposed to do, I don't think it's worth $150, at least not in my shack. Here's another podcast I came across, and of course, last month I came across this where Arduino goes pro, and here we go again in a whole different area, and I come across Arduino goes pro from another angle. It's a podcast called Moore's Lobby, and that might be another one that you can check out, and if you got nothing to do, maybe on Saturday, since you'll be busy on Sunday with the other podcast or the TI stuff. This caught my interest because it kind of made me think about our especially our SNA days and all the thousands of emails that project generated and all the data and everything like that. Especially when we were all 3 or 4 of us were all doing the same thing, coming from different angles and getting all this data and trying to make some comparisons. So maybe if we get one of our future projects going up with our collaboration, maybe there might be something along these lines. Not necessarily a Picolog cloud, but something else. But there might be something to talk about. Like I say, if we get a little more complex project going and we're going to be sharing data again and whatnot, there might be something there that we can do. 2021 marked the year we saw the first functioning 2-nanometer chip, and that was done by the team at IBM Research. Oh, and I make note of the Moore's Lobby podcast, and it's allaboutcircuits.com. Actually, I think that's where Al Wilkie is with his webinar too, is all about circuits. I think that's the one. But anyway, so here's some of the samples of the podcast they have on there, and one is the IBM Research is inventing what's next. And of course, the Arduino goes pro, disrupting the world of automation. And then another one I thought was interesting was NASA astronaut Matthew Dominic on critical engineering and aerospace technology. So there's a little more upscale, shall I say, of a podcast, really, a little deeper stuff that may not necessarily be all that homebrew kind of thing, but some interesting topics nonetheless. And that would be it for me.
Okay. Thank you, Peter. Comments from the group? Any questions or discussion?
That was a good selection of websites, Peter. That 2 nanometer chip, what does it do?
I don't know. It was just a little quick article that I came across on one of the news feeds, and it just said that they've now got a functioning 2 nanometer chip. What it was, I don't know.
The communication was NFC, right? So that means it's going to be very, how are they going to find and pick up those, you got to be within, what, a meter or something?
No, that's, I just pulled it up on the website here. That's the feature size in the microprocessor. So that's the smallest feature they can produce. So it's for, microprocessors and memory and stuff like that. So it's not necessarily new.
About the path link being the greatest barrier to speed of computer.
Yeah. So they're talking. Yeah. So they're talking up to 50 billion transistors on a chip now with that.
15 billion. Oh
50 billion. 50.
Oh, 50.
That ought to be a lot of heat.
Yeah, I wonder what voltage it's going to run at. I'll bet it's a volt or less.
Yeah, probably.
Wow.
And then I was just reading something not too long ago about light, using light now, getting rid of electricity.
Oh, yeah.
But usually these these 2 nanometer nodes, they use them for the most expensive, biggest chips. Microcontrollers are usually using older technologies, like they're 28 nanometer, 56 nanometers. So we probably won't see a microcontroller at 2 nanometers.
These are, you're right. These are the very high end server micro processors and stuff. Yeah, at least that's what they're saying here. So
IBM's always a bit ahead of everybody else, but no one ever uses their chips.
So how does that work?
So you won't really see it implemented until someone steals it.
Yeah.
So it'll be on eBay soon.
Yeah, very likely. Well, that's what happened in Naboo.
Wow,
Have you, Peter? Have you listened to that Moore's Lobby? Any of the episodes?
I started to listen to the Arduino one, but I didn't get quite through it because I had that big trip I had to go to.
Mm-hmm. Right. Okay.
That's my excuse.
That'd be a good time to listen to it.
Yeah, not with 5 other people in the car. How long do you think that would last?
Well, you put them all to sleep in the first 5 minutes, and then you can listen to it.
Well, I saw a nice beam antenna in Old Quebec City there, and I was the only one that was thrilled at the site. So that kind of tells you.
All right, very good. Okay, all right. Well, thank you for that, Peter. So, Kevin, why don't you?
Okay. I had a couple more things to add. One is I don't know. Well, I know you, Eric. I know you listen to that Ham Radio Workbench podcast. You listened to the one on diversity receivers?
I did, yes. Yeah.
I had no idea. I now want to do a diversity receiver to get rid of noise at my QTH here.
Yeah, that's kind of interesting.
I had no idea. They have a whole podcast on diversity receivers, and this guy explains how they work and what you can do with them. And very interesting. It's definitely worth the 2-hour lawn mowing exercise or whatever or maybe snow shoveling soon. Well, that's, no, because the hardware is kind of fancy. It's, the front end could be maybe the DCR or something, but basically that you take a noise probe, like a really crappy antenna to pick up the noise, and then you have your other antenna. And then by phasing that in with, the 2 signals, and you phase them in and invert it, you can get rid of a lot of the noise. So that's kind of the gist of it. But to do that, you kind of need like two coherent IQ streams is the easiest way to do it technically.
Yeah.
So you do it digitally, basically.
Are they doing that with an SDR?
Yes.
Yes. Yeah. Yeah.
Yeah.
Interestingly, it's not really new, eh? Like this
No, this has been around forever, but
Right.
and obviously there is ways to do it analog, but
Why not just convert to noise canceling headset technology and jack it up to RF?
well, I don't know. It was just interesting. I had no idea the possibilities of it.
I mean, I guess it is kind of a noise controlling circuit of sorts,
Well,
right?
it's a direct noise canceling circuit because you're picking up a sample of the noise and using that to negate the noise in the area. So it's custom made for whatever noise you happen to be picking up that day. And this guy even made a point. He says, my neighbor on one side had a plasma TV or something like that. That was a huge noise generator. He actually put a separate noise probe on the side of his house near the neighbor's TV. So when a neighbor had it on, he could cancel that noise better than, where his other noise probe was or something.
So
He's
this
quite
wouldn't be
into
for
it.
broad spectrum noise, that it would be for specific spiky noise.
Well, yeah, it's for like band noise, right? Like he said, he's got the same problem I do living in the city here, right? It's like 40 meters is always S9 plus. So, you can't do much with weak signal stuff. But he says he gets it down to a very usable level with it. So anyway,
You should put a receiving antenna up in North Bay.
Well,
Bay.
that's what is it, Mike?
yeah, VAW, the guy from Flex Radio.
MW, Mike Walker. Yeah, that's
Yeah.
what they said his solution is. He always has S1 noise because his system is up in his cottage somewhere up north.
My daughter lives up north of Aurelia, and they have a nice big backyard. I haven't broached the subject yet as to if I can put a little SDR with a radio up there for listening, but the time is coming.
Yeah.
Maybe I'll give them a little extra, Christmas present this year and then broach it.
Well, as Peter knows, I have enormous noise on 40 meters as well, and been trying to find a solution for some length of time. I'm fairly certain it's a hydroelectric, issue, insulators and the like. This sounds like an elegant solution.
I definitely go listen to the podcast. It's not the most recent one. I think it's the second most recent, but Diversity Receivers, worth the time to listen to it. I think you'll enjoy it.
Which podcast? Is that the Workbench podcast?
Yeah, the Ham Radio Workbench. So anyway, that was just...
That's a good one.
I listened to that, and I thought, I really wasn't that keen on listening to it, but I listened to it when I go for walks at night, and when I started getting into it, I thought, holy crap, why did I not know this? Anyway, so another shiny new object, right?
Yeah.
Well, that's okay. That's a really good one.
I think it is, or it certainly has potential. But so the other thing was,
It'd be a good table talk exercise to figure out how to homebrew one.
yeah, exactly. And speaking of chips, I assume you can see this.
Yep.
I ran across this, and it's like, we do RF amplifiers and stuff, and then here's an RF amp. So, certainly within our frequency range, 24 dB, and it's 26 cents. And all you need is coupling caps on the front and back.
Good God.
And it's 50 ohms, and they're in stock. Which
in Canada?
In these days, this is New York, so it's in wherever it is, South Carolina or North Carolina or something, I think.
It's at least on the continent.
It's on the continent, and they have 39 in stock as of right now. But I just thought, geez, for 24 dB for 26 cents and 50 ohms, sure, it seems to cut out a lot of the stuff around a transistor amplifier.
Well worth trying to practice soldering that small of a package. I've done it. Matter of fact, I think I gave a demo of that several months ago on that on the 363 package. It can be done.
Yeah, but and it is small. It doesn't take up a lot of room. So anyway,
What are the dimensions?
How's it powered?
Well, let's see here.
It's probably through. You got to do on the input output. You got to put RF blockers. Yeah,
yes,
exactly.
So that's why I said you need input and output caps.
Yeah,
and
then you power supplied them one of the pins on
Yeah.
one of the input or output pins.
Yeah,
It's,
there's a
it's how many pins?
No, it's a separate pin for power.
yeah, it's a
How many
separate pin for
pins?
power. It's a 363 package. I think that's 6 pin, isn't it? Yeah,
Yep.
Yes.
like
It's
6
six
pin.
pin. Okay,
Yeah.
yeah.
6 pin.
No, because I think I thought Peter was like those Mars, because the Mars it's got like 4 pins, 2 are ground input and a 1 pin input, 1 pin output, and VCC.
Yeah, on the Mar,
Yeah.
your power. Yeah, on the Mar chip, your power in the output pin.
Yeah, so that's
Yeah.
what I thought, because as soon as you start doing that, then all of a sudden you got to make sure no RF whatsoever goes on that power rail,
Yeah.
right?
But this is a separate pin for it. So
That might be a
and,
worth
and
thing.
3.3 volts.
That might be a worthwhile thing to play around with, because at 26 cents, I think it's quite a bit cheaper than the Mar chip.
Yeah, and even if you can't solder, you can get one of those breakout boards, right?
Well, you still have to solder it on a breakout.
Yeah, that's true. Yeah.
But having said that, and having done it, it can be done. Just take your time.
For 26 cents, buy a few and practice.
Exactly. And by the time you get to the 12th one,
You'll be all right. Yeah. Just don't order the entire stock for yourself.
Now, having said that, just to add there, the breakout boards for that size of a package is a little bit more difficult to find, if I recall. And when you do find them, they are a little bit more on the pricey side of things. Yeah. Now, it just may mean I haven't hit on the right site yet, but anyway.
Yeah. So I don't know. I ran across that and I thought, oh, that actually sounds like something that might be really useful in a project. For 26 cents, you could easily have a couple of really nice amplifiers in there.
What's the B or an LMB? What's the B?
Low noise something. IF amplifier. I don't know. I'm just guessing.
Low noise block.
Low noise blocking IF amplifier. I don't know.
Low noise block.
Okay.
The Mars 6, the noise figure is 2.3 dB. What's
Okay,
this? The noise
3.9. 3.9 dB at 950 megahertz.
So it's almost twice.
Yeah.
Well, what's the noise figure at the frequencies we'd be interested in? Is there a graph?
I don't know. You'd have to look and see.
Yeah.
There's usually lots of charts here.
I don't know if it's linear.
Yeah.
Look at the Kevin. Could you go to the PCB layout? The test right there. Scroll down right there. Stop.
Yeah.
Yeah. Let's see. Yeah. See how much decoupling. All those P. Are they all decoupling? Yeah, that's all power. Pin 1 is power, right?
Yeah, but I think I don't know why they give you the option of those. It's like you don't need all of them. You just need one of them, I think. Yeah, a decoupling cap is used on one of the positions, P5 to 24. So why they have so many, I have no idea.
That's P5 to P24. What about P14, 15, and 16?
Doesn't say.
Yeah, anyway. So yeah, no, these things are very, very sensitive to noise.
You pick a position based on the inductance of your traces, and so that at the frequency of interest, it all works out. But that's how you have to do it.
I put the link in the chat if anybody wants to open it up and take a further look at it. So you can grab it from there.
Okay.
So anyway, that's another thing there. And then what I was really going to talk about, let me share the other part of my screen here. Window, and I want this. Okay. So anyway, back to my knowing our test instruments kind of thing. I ran into this at work. There was we needed some help, and one of our vendors sent over a dude that knew about some software and had a little bit of hardware, but really barely knew how to use a meter. And he's checking continuity with the beeper function on his Fluke meter, which it was a good meter, Fluke 87, I think. And he's saying, well, I'm trying to trace this short, and it's like, well, there was no short per se. It was like, I don't know, 30, 40 ohms, whatever it was. It was an acceptable value of resistance, but he thought it was shorted because his meter was beeping. I said, you know that those beepers don't work on 0 ohms. They have some level of resistance that they trip at. Oh, I didn't know that. And I thought, oh, there's something to talk about. And so anyway, I have 3 meters in my possession at the moment. An old Fluke 73 that used to be my backup meter, and I also have that Tektronix TX3, which is no longer available, and a Keysight 1282, and that's the newest one. So the Keysight is probably by far the more accurate one, but the TX3 is really good. I mean, it's taken a beating, and when we did our calibration night with Simon, I don't know, however long, forever ago, back at the last time we did that, it was like spot on with everything. So anyway, with these meters, I thought, well, how much difference is there between them? Like when they measure stuff, should I, does it really matter? And then I'm just comparing between them, not to any kind of standard or anything. Because meters don't always measure things the same way, right? They use different algorithms, which is actually becomes obvious later. And you know which one's the best one to use, and maybe it doesn't matter sometimes, but sometimes it does. So even things like the beep resistance, so my Fluke doesn't, or the 73 didn't have a beeper on it, but even just so for the tech to the Keysight would trip on something less than 22 ohms. It declared that was a short, but the TX3 it's somewhere between 47 and 72, and that just happened to be 2 values that were in my resistance decade box switching thing, so it's somewhere in there. And then I just measure the voltage at there, so you can see they're using very, very low voltages, and also I've calculated the current that it's using as well. And these are significant only because the voltages are so low it won't trip a diode, right? So which makes sense, you don't want it to. So that was one thing. And I did have one meter at one time, and I forget what it was, but it was almost 200 ohms before it would stop beeping, which is really high, I think. 200 ohms is not a short. And then I thought, well, what happens when you measure diodes? And so anyway, there's a graph of some different diodes and the voltage and current traces, like an IR diode, red, orange, green, all the way up to UV. So some of them are quite high voltage. I didn't realize some of them were this high. When you're getting up to a couple milliamps, you need a few volts to break them down. Which, when you look here, you go, okay, well, a Fluke 73 only uses 2.5 volts open circuit at 0.5 milliamp. The TX3 is roughly the same, but the Keysight uses 3.3 volts. So I don't know that it matters at these low current levels. The Keysight has a 1 milliamp current source, and it uses it for other things as well. And these are around 0.5 milliamp. So you're way down here on the curve, but and that's why I'm not sure it would make a difference. But it was I just thought it was interesting to know that the Keysight one is like a third, 30% higher voltage available to check diode drops. And measuring megohms, okay, not much difference there other than the TX3 consistently uses lower voltages and lower currents than the Keysight does, and yet the accuracy is comparable for sure. So I'm wondering what kind of circuitry they have in there to be able to get the accuracy, compared to what the Keysight's doing. But anyway, that was, and even measuring current. So the Fluke 73 only really has a 10 amp scale, and it's stuck with 57 milliohms. These are a little bit higher at that kind of scale, and it doesn't have a milliamp scale, even though it says it measures down to milliamps. You got to think that if you're measuring, like, say, 10 milliamps with this kind of resistance in the circuit, it's not going to be very accurate. Because it's a bottom end meter, so it's not likely to have a very precise analog to digital converter. And I would think at the bottom end, you're going to be in the mud, right? Whereas these other meters, they change the burden resistor so you can get a higher voltage and keep your accuracy and precision up, right? So that was just interesting there. So I wouldn't use my Fluke 73 if I wanted to measure milliamps with any kind of accuracy.
Kevin, it's also speed. They can just average for longer and get more accuracy that way. So
yeah, but I also wouldn't expect that from a bottom end meter either. But I agree. Yes, you can get a really accurate reading if you want to listen to it for a year, right?
Well, it's like a few seconds. So it might.
Yeah, no, I know. Yeah. So the other thing was this AADE tester that we built at Buildathon a while back. We know it doesn't do very well on microfarads, right? It does fine on nanofarads and picofarads. And I thought, well, I just wanted to characterize that a bit. So I measured a 10 microfarad cap. The AAD1 showed 0.2 microfarads. The TX3 showed 7.2 and the Keysight 8.9. And the interesting part is that this AADE seems to be using like a very small oscillator signal, right? So it's, as you can see, like it's using, when it can measure something, in this case, a 0.1 microfarad. So it's using 0.09. So it's, right there. It's got a 50 millivolt signal at 65 kilohertz. And so when you try and so it's maybe some kind of bridge configuration. I don't know what's inside the thing. But obviously when you've got a little signal like that with a very big capacitor, it kind of, it can't develop enough of a difference to give you an accurate reading, I would argue. Whereas the other meters here, so the TX3 and the Keysight one, they're running like a triangle wave. So basically they've got a current source and it looks like they're just injecting the current into the capacitor and monitoring the slope on the resultant, they're monitoring the slope of the resultant triangular waveform that you get from that current source. And then they do their math to calculate what kind of capacitance you're getting. And you can see it, it's much higher voltage. And also, the frequency changes, right? Based on the capacitance. This one's 10 microfarads. This one's 0.1 microfarads. So anyway, it's much slower, but more accurate, right? I mean, you look at, so even measuring a 3.3 microfarad here, it's still only 0.12 microfarads, which is ironic because that's even less than what the 10 was. Oh no, that's right. Sorry, that makes sense, but it's definitely not linear. Whereas this one's 3.48. Actually, you can see how close these meters are. Well, I said they don't agree, but obviously they're pretty close here, like 3.48, 9.7, 956, 1.16, the same, 137 to 141. And the interesting one is that the leads on both these meters add between 20 and 40 picofarads, depending on how I hold them or set them on my desk or whatever. The interesting thing is the leads on the AED are really, really short and they don't matter much. And I can't get more than a few picofarads difference out of them. So that was interesting. So for smaller values, the AADE, like down in the picofarad range, it's probably better, or at least more repeatable, only because you don't have to worry about what your leads are doing and where they are. Whereas on the AED one, you pretty much can't mess it up. So anyway, I thought that was interesting, especially on the small. I figured the more expensive meters would be better, but not really, not unless you're going to use short leads. So anyway.
Did you check the batteries on the AADE? Because it has trouble with high capacitances.
Yes. I'm not sure. You mean check the battery voltage?
Yeah, like maybe your batteries are weak on the AADE.
I don't remember checking it, but I will now. But I seem to recall this was an issue at the time we built them, that we were checking some, and it was they weren't that good on like higher capacitance. But when I'm done here, I'm going to turn around it because I have it behind me. Yeah, I do. I'm going to turn around and pull out the battery.
And I found that as well. The higher capacitance, it's, it wasn't very good.
Michael, you had your hand up?
Yeah, just a comment. I have the AADE meter as well, and I had noticed that it doesn't work very well on capacitance. I couldn't tell you what values they were, just don't remember. But I did notice that it's they're just not accurate at the value of the things I was measuring, which are probably, now that I think about it, in a microfarad range. So I don't know.
Yeah, and you can see from my table here on the bottom.
Yeah.
So it's not bad. 10 nanofarads. Okay, it's within 10%. And it's within 10% all the way down, pretty much. But even comparing to the other ones, yeah,
That's really interesting to see. Thanks for showing that.
And my battery is 8.8 volts actually. Frank, you had your hand up?
Yeah, just one comment about the AADE. And yes, that is true that it is very poor when you come to larger capacitance. But also what made me think about the lead length is the optional adapter that we made for it. And some of you got a hold of that, others maybe missed it. But there was a little adapter that you can plug in to the leads, and it reduces the lead length to 0. So you get a lot more accuracy in the small capacitor range.
Yes, and I actually have it on my meter. I'll show it when I'm done here.
Okay.
Hassan, you had your hand up too, I think.
Yeah, so the incorrect value is the electrolytic, and the frequency is 65 kilohertz. Maybe the frequency is too high for electrolytics.
Yeah, I was thinking that too. The ESR of the electrolytic is going to be a lot higher, right? But I tried to measure it. Like I looked at these waveforms on my scope when I was measuring it, and I was just getting noise. Like it was just 60 hertz with some noise on top. So it was a much clearer, proper AC waveform with the smaller capacitor. I think it seems like a drive issue. You know what I mean? Peter, go ahead.
Yeah, I was going to say, and then we did the bench tester project, and I found that device was much better on measuring the larger capacitive values, but it wasn't as good as the AADE on the lower values. So instead of one supplementing the other one, you need both.
Yeah, and that's kind of the gist of what I'm, I guess, trying to say here is that if you know your test equipment, there's some meters you don't want to use depending on what you're doing, or you have to pick your poison, right?
Yeah.
So, Michael, you had your hand up.
So just another question. Forgive the ignorance here, but when you're measuring the frequency, what you did was you connected the capacitor across the device, right? And you used your scope and connected the scope across the terminals of the device as well, right?
Correct.
Yeah. Okay.
Yes, that's what I did. And Dwayne, you had a comment?
Yeah, the method that the tech and the Keysight uses is it's not really producing a triangle wave. What they do is they put a constant current source into it, and then they measure the time constant till the capacitor, till the voltage reaches up to a specific point. I think it's 0.4 time constants or something like that, and then they go and short it back to ground and repeat the test.
Oh, okay. Yeah, I mean, to me that looks like it looked like a triangle wave on the scope, because if you're charging a cap with a linear current or with a constant source, it's not a triangle wave. You're right. It's more like a sawtooth. That's more accurate, I think, from what you're saying. But yeah, that makes sense then from what I was saying. So anyway, that I thought that was interesting. So I know what meters not to trust now for certain capacitances anyway.
Do you have the bench tester?
Yeah, I do. I tried to include that, but I wanted to do some of this kind of stuff, like how it's measuring it, and I put it on the scope, and because it tries to figure out, is it a transistor, is it this, is it that, every time you put it in there, there's all these waveforms and voltages popping up and going away, and it's like, okay, maybe I'll just leave that one. That's a little too complicated.
Right.
But I could have just done a comparison, I suppose, but I chose not to.
On the capacitance value.
Yeah, just on the capacitance, yeah. But maybe that'll be part 2.
That's a good idea. I'm inking you in for that.
That'll be a real short one. And just excuse me. For a note, I don't know what the accuracy is supposed to be on the ADE. On the TX3, it's rated plus or minus 1 to 3% plus 3 counts. That doesn't make sense. Plus or minus 1 to 3%. Oh no, sorry. That's over. The accuracy changes with the range, the capacitance range. That's why it's 1 to 3%. And the 1282 is 1% plus 5 counts. So 1282 could be the more accurate one most of the time.
What do you mean by 5 counts?
Well, if you've got say it's got a value of 1,000 on there, so it's within 1% of that, and up to 5 least significant digits.
Oh, I see. Okay, gotcha.
So my conclusions were, the commercial meters are more accurate versus the AED, and they're comparable in the lower ranges. Don't use the AED for large capacitance, relatively speaking, microfarads, and watch long leads, which is a good thing for anything when you're measuring low capacitance. Diodes, yeah, whether it makes a difference or not, I don't know, but I didn't know that some of the diodes had that high of voltages. So if you're trying to match diodes, make sure you use the same meter all the time. I think that's fairly obvious. And beeper functions, if you understand the beeper doesn't beep on just 0 ohms, that there's some kind of resistance that it's measuring, that's fine, because depending on the circuit context, right, 10s or 20 or 50 ohms is not a short. It may be a healthy circuit. So just keep that in mind when you're using it. And that's it. That was this was I think this is what you were talking about, Frank, with the little circuit board on the front, and then you can stick,
that's exactly the one. Yep.
And you can stick components in here.
You can plug them in to the smaller leads there, or a large capacitor. You can put them underneath the contacts. Yeah.
Yeah, and you can even use the surface mount stuff. You can put it across the gap there, right?
Yep.
And it'll measure it there. So, sorry, was it Michael? You had your hand up?
Howard, I think.
Howard, sorry.
Yeah, just a quick question, Kevin. I have a Keysight 1200, the 1241. Do you find the beeper tone really anemic on yours?
Yeah, it's not that great, but I also almost never use it, because I'm more interested in finding out what the real resistance is, as opposed to, is it continuous or not. Even if I'm checking continuity, I still use ohms. I don't know, it's just my personal habit.
Okay, that's good. Good point, because mine is really low, and I complained about it and got a hassle from them, and I didn't bother sending it back. Maybe I should have, but that's a good way to check.
It seems okay when it beeps. It catches my attention. So if that matters, if there's a voltage nearby or whatever, because it has the voltage sense built into it as well, right?
Yeah. Okay. Good. Thanks.
Dwayne, I think you had your hand up again.
Yeah, for measuring small capacitors to get rid of lead lengths, I had to make up a set of just a banana plug with an alligator clip soldered to the end of it for both of the contacts, for both the leads. That way it gets rid of all the lead length, and you can just stick capacitors in there real quick.
Oh, that's a good idea. Yeah, that's a good idea for sure. Peter?
it reminds me when you talk about this beeper function leading down the garden path. We had an electrician that wasted a fair bit of time one time trying to track down a short. And it turned out that what he was measuring was the resistance on a sonalert, which was very low impedance. And of course, it tripped off his meter and he thought there was a short. But in fact, there wasn't. But I find the only time I really use the beeper function is when I'm measuring something that's on the bench right in front of me for continuity. And that's pretty much it. Yeah, once it starts going a little bit further afield and things like that, I'm using resistance.
Yeah.
So,
Well,
so what's the minimum resistance then to determine if it's a short or not? Or continuity?
Well, it depends on what your project.
Oh, that's true. I see what you're saying. Okay.
It depends also on the meter, right? Like my TX3, it was like 50-ish ohms maybe, and the Keysight meter would trip below 22 ohms. But as to Peter's point, that's exactly what this guy was doing that triggered this whole thing, because there's a hydraulic solenoid in the circuit, and they take 2 amps at 24 volts, so they're 12 ohms. It's not a short; it's just fine. It's exactly what you want, but when the meter beeps at it, so it thinks it's a short.
I never thought of it that way.
Sorry, somebody had their hand up and I missed
Peter.
Oh.
Actually, the example would be if you're working on your project and you're looking for shorts, you're going to be using the resistance function on there, and you're going to kind of know roughly, since you built it or looking at the schematic, what your resistance is going to be to ground. So you'll know whether or not that's an acceptable value, whether it be 50 or 1K or whatever. And then using the beeper function in that case, probably I really wouldn't use it all that much, because if you're looking for, say, ground connections and making sure there's a good ground, I'm still looking at on the resistance scale. So really, the continuity may come into play. Maybe if you're checking a bad connection outside on your antenna, I don't know.
My personal feeling is that beepers should be taken off meters, and they only belong on the $9.99 Canadian Tire meter that the average handyman uses on the weekend. But anybody that's doing any kind of serious troubleshooting or industrial, I don't think they should be in there. And if they are using them, they should know what it's limited to. So, Frank, go ahead.
Yeah, I would like to make a comment with regard to that, and I do find them very useful, the beeper, in one particular situation, and that's when I'm winding toroids and soldering them. Believe me, I've saved the day lots of times, and I know that toroid is in there, and I got it right lead in the right place.
Those toroids, you can never escape them.
That's true, but you know what, Frank? I still use my Keysight meter for that, because one thing about that meter, it reads down to like 0.000 something ohms, like 4 decimal places, and it's repeatable, and it's slow. It's like to Hassan's point, it gets the accuracy because it's a lot slower than the TX3 meter. But if I wanted to measure, like, am I measuring a full winding or half a winding? I can measure the difference with the Keysight meter. It'll measure that lower resistance. It's actually quite impressive. So, but anyway.
Very good. I don't have one of those, so
I wouldn't either. Yeah, no, I wouldn't either if I couldn't expense it through my business. So
now that we're having this chat about these low resistances, it's too bad Dave VE3 EAC isn't on here tonight, because I think he's homebrewing a project for extremely low resistance. I'll have to ask him about that.
Oh, really? And why is he planning on doing
I'm not sure
that?
why he's doing it. But I'm sure it was him that was talking about it a while ago, but it hasn't come up in conversation for a while. But I will bring it up at our next lunch next week and see how he's doing with it. But he had some use for it. It was purpose built for a project, but I can't remember what it was.
Okay, interesting. Anyway, so that was my mini deep dive into test meters this week. So anyway, Eric, back to you. You're in charge.
Yeah, I think that answered the question. I was going to ask it about 5 minutes ago. It was like, should you ever use the beeper for checking for shorts? Answer is no, right? Bottom line. So,
And in my opinion, I mean,
Yeah.
it does have its uses, but just be aware of its limitations.
right. And Michael,
The question of the day is, does having two crappy meters from Sayal make it better than having one? You know, I don't know. I'll have to see if I can figure out how good these things are. They're the Uni T meters. So I got two of them, but I think they're pretty good, but I haven't done the checking like you guys have done.
Well, I still don't know the absolute accuracy of these. This is all just relative to each other. So, but I mean, you know, the 1282 did come with a calibration certificate, but it's long out of calibration now. So, but I don't know. I think, Dwayne, you've spent more time in that world. I would think a Keysight instrument is probably pretty good lineage, or even a Tektronix one.
hang on. Isn't every measurement in the world relative?
I think that's true, yes.
Uh-oh. They're fast and furious. I don't know who was first there. I think Hassan?
Yeah, I have this old HP desk benchtop capacitance meter, LCR meter. It's made of discrete chips, and it's a beast. And it gave me good results for a long time, but now it doesn't work at all. But I bought it for like, I don't know, $100 or something, or 200, I think, and it worked beautifully. But the problem is, I thought I'd be able to fix it, but I don't think I can. But if anybody wants it, or anyone knows has any ideas on what to do with it, just let me know.
You can drop it off at my place if you want.
Sure. Yeah. It has a good few features. You can select between 120 hertz and 1.2 kilohertz. Usually the results are the same, but occasionally it does diverge quite a bit. But yeah, it's really neat. It's entirely made of discrete parts, and it's like a huge monster boat anchor. It's probably from the early 80s.
Oh, sorry.
I was going to say, why don't we maybe we should think about having Kevin mentioned it way back at Safe City. We had a calibration night there that went over very, very well. Maybe we should organize a calibration day one day at Eric's.
Mm-hmm. Then we have to make sure Simon's invited, right? I think that's where it should happen, is at Simon's.
Yeah, I agree.
Well, that's true too.
In fairness. Although then again, I think I probably have one of each of what Simon has too, somewhere in a box.
No doubt.
Yeah, but they're probably all out of calibration because you haven't used them.
Yeah, absolutely.
You could take yours over to Simon and calibrate yours and then bring them back.
All right.
So one day at Eric's. One-stop shopping at the IDAE.
There you go. Frank, you had your hand up?
Yeah, while you were talking, I just remembered this meter right here.
Ah.
Wow.
That's an old timer that I've had for years and years and years. Even have the manual that goes with it. And I haven't used it for a while, so I don't know what the accuracy is, but just as a point of conversation as we go.
Is that manual on a stone tablet?
Good one.
All right, you can smack me later.
Frank, make some comparisons and let us know.
Yeah, I'll have to.
Hassan, your hands up.
Yeah, I'll show you the meter I've got. Can you guys see it?
Oh yeah.
I check out the manual. Stone tablet. Comes right out.
Hey, Dwayne.
Yeah, some of the old meters were and stuff like that. The first digital voltmeter I ever used was purely mechanical. It was a Wheatstone bridge driving a motor which turned a mechanical rotary counter.
Holy cow.
You still have it?
Yeah, I was going to say, do you have it?
No, that was at the company I worked at in like 68. 69.
Wow. Okay. Oh, Frank.
The analog computers like this still have their purpose, and that is sometimes when you're adjusting a tuned circuit and you're looking for a peak, a digital meter has a difficult time to read the peak, but I'll use this meter in that particular situation.
Definitely good for looking at change, right? Analog rules.
Yeah, exactly. And then you just the meter will change as you go ahead and adjust the circuit, and you can peak it and say, okay, that's it. You know, you got that peak.
And you're not really worried about the value in that case, so the accuracy isn't that important because it's the relative. You're looking for the peak, no matter what.
Just the peak. Yeah.
That's one of the functions I built into the RF voltmeter function on my the SNA that I built.
Oh, peak function.
Yeah, the analog meter function.
I've got one question here, and this is I just want to confirm something you said early on, Kevin, in your presentation there. I assume whenever the phrase DC to R to 2.2 gigs or whatever, DC means is just a fancy way of saying 0, right?
Yes.
Yeah. Okay. All right. I've seen that many times, and I just want to make sure that that's.
Oh, yeah. I mean, they say that, but then you have to put blocking caps in and out, so it's not really DC. It's something above DC, but it's still within our range.
All right.
To be useful. So.
Okay. Very good. So I think he was on the call when I brought this up, but Dave, did you want to chat a little bit about your musings lately on the board with regards to 3D printers, laser etching PCBs? Are you still awake?
I thought you were going to say, do you want to talk about your musings about chickens? I was going to go, woohoo!
No. But I mean, we can put that on the agenda if you'd like.
Well, actually, I haven't used it for so long. Yeah, actually, you know what? Peter is probably, speaking of tools.
Hey,
nice.
Good segue.
Listen, I don't mind taking the drive to Paris.
Peter's probably going to throw something at me here going, don't you know how to do this? Because this is electrician stuff. So what happened, in my backyard, I've got a gazebo, and I had an electrician come and put electrical power to it, because I wanted to make sure that if I sell this house, I'm not going to violate some building code, running power out to like an outdoor structure, right? So anyway, he ran it out there. It was working great. We put a little ceiling fan in the gazebo, and we've got little lights, these lights going around. So it's really cute and nice. And then my son had a friend over. He goes out there, turns on stuff, and it's dead. There's no power. So, I go out there and I start poking around, and, it's there's no electricity. There's no power coming out the socket there. So traced it back to where the lead goes to because it's slaved off of a receptacle on the outside of the house. So I went there, checked that receptacle, and it's dead. So I'm going, okay, there's got to be a GFI that receptacle. Well, I go back to the breaker, make sure the breaker's not popped, make sure there wasn't a GFI in the breaker, and there's nothing. So then I thought, okay, that receptacle has got to be slaved off of a GFI somewhere, or some receptacle's gone, right? So I'm going around the house and I'm checking, looking for a GFI, and I can't find anything. So finally I start Googling around, and they said, look, you got to trace it. So I got this. I don't know, Peter. Have you ever used these things? It's a tone. Can't
Yeah,
really see it.
so, yeah, to find a break in the wire under that you can't. Yeah.
Yeah, it's a tone. You can't really. I don't have the light. I got to get my light on here. How do I turn my light on?
Is that to trace the circuit to know which breaker?
Oops.
You can do that with it. Yeah.
It's a tone. It's a tone generator. There's a tone. This generates the tone, and you connect it to the wires, the electrical wires, neutral and hot, right? And this generates a tone, and then you've got a probe, and you just go in the wall and you trace it, and you can see where the wire runs.
Oh.
So I was running around with this thing because it makes a god awful loud noise. Does it have a battery in it? I'll turn it on. Can you guys hear that?
No, turn it up.
You're right. That's annoying.
So
Did you have clothes on while you were running around wildly with that?
I'm running around with this thing, and my wife's going, "Do you have to do that?" So I'm running around all over the place trying to trace this thing down. So finally, I saw it's going into the garage. The wire's going into the garage. I'm going, the GFI's there. So I'm going around, nothing there. My wife comes out, and she's going, "What are you doing?" And I said, "Well, I'm trying to trace this. Look, see the wire, and I'm tracing it, and the wire comes out here, and from here, I don't know where it goes." And then she goes, "Well, did you look outside? Is there another receptacle outside?" So I go look outside the front of the house. There's a GFI. So I go reset that, and everything worked. My wife, the electrician.
You just wanted to spend money on another piece of test equipment. That's all.
Yeah. Well, you know what? I bought it, and you know what? It works. Because I thought, okay, I was going to buy this thing, and it's a piece of junk. I really thought I was going to, because like the good quality ones are hundreds of dollars. This was like $40.
You could have homebrewed it.
What's that?
You could have homebrewed one.
Oh yeah, that's gonna go over well these days. Take me a month to homebrew it and troubleshoot it and make it work. But I have to put a pick in there.
Got into a gazebo in the wintertime anyway.
Yeah, I have to put a DSP in there, you know. No, anyway, so that's my latest musing, chasing wires around the house. It's RF, but it's kind of RF. It's low frequency. It's a frequency.
Baseband.
All right. So, did you want to touch on the 3D printers at all? Or have you?
No. Well, I've just been. I finally pulled the trigger and I bought a 3D printer. I bought the Ender 3, okay. So that's coming. And I just, as I was looking how to use it and mods and stuff, I saw a whole bunch of people slapping lasers on this thing, and I thought, oh, that you could use this to like cut stuff out. And I started checking, and there's all kinds of stuff with people slapping lasers on. But the interesting thing I saw was people using lasers to etch PCB boards, and this is not to burn the copper off. It's to actually etch it. So what they do, they spray paint the board black. They take a flat black spray paint, and they spray the board completely black, and they put it down, and the laser goes and burns the places you want etched. So it's kind of like an iron, except it's inverse.
Oh, right? Put it in the chemical bath.
Yeah, it puts the toner. Normally, a printer will put the toner down on places where you don't want the etchant to remove the PCB, the copper. But in the case of laser, you're burning away where you want the etchant to take away the copper, right? So it's actually, you have to print the inverse of the board, and the laser goes and burns away the paint. You clean the paint off, you put it to etchant, and it etches it, and they get right down to, you wouldn't believe how small the traces can be. And you could use a low power laser for doing this.
Can you get a SOT 363 out of it?
I think, man, Google it. There's like on YouTube, there's a ton of people. There's that Hackaday article I posted to you. That came out November 2021. It came out this month.
Did you order
October or November, and it came out, and it's now, and so sure enough, I go on YouTube, and there's a bunch of people who are actually doing this, and they've got pretty good success.
Did you order a laser head?
No.
Where are they suggesting that you order them from, Dave?
What's that?
Where are they suggesting you get the laser head from?
That's the whole thing about these lasers, the quality of these lasers. They were saying that, because I looked into it, and they were saying these lasers, because it's a laser diode.
Yeah.
These are all laser diodes, right? And they were saying the Chinese, and this is all stuff I'm seeing on YouTube. I have no empirical evidence. And they were saying what they do, they pulse the laser.
Yes.
So they apply a TTL square wave to pulse the laser on and off, because it has to do with the duty cycle and delivering the current, because it's like a buck converter. These things uses up a fair amount of current. It's a device that needs current and needs a large amount of current. And if you're powering it from a small current device, it can't deliver it. So the way they do it is they do that buck converter thing where they charge a capacitor, discharge it, then charge it, and then discharge it. So they're doing that, and they've got these boards inside the laser heads, and it's actually delivering more current than what's coming in, but it's delivering it in a duty cycle, right? And so it's fast enough that it can etch and burn and cut materials, right? And those boards they use for doing that is crap. So that's what a lot of people are saying, and those boards tends to burn out the lasers. So the lasers don't last very long, the ones you get from China. But I've been seeing people modding them. They take apart the lasers and they replace the boards, and they put in better quality parts, and they're able to use it much longer. But it's kind of interesting that, so I know that a few people had 3D printers. So my question, and I posed this in the forum, my question was, has anyone looked at this? Or has anyone tried this?
I do have an Ender 3. I haven't tried this yet. Sorry, go ahead.
Yeah, I've got a laser head for my CNC router engraver that I haven't tried that with yet, but it's one of the things I want to do one of these days.
What do you use it for, Dwayne? Etching? For like etching stuff on materials, or do you cut stuff with it?
Well, I use the CNC engraver for doing circuit boards at times and for other things. But I do have when I ordered it, I bought a laser head with it that I was thinking about using for making circuit boards.
Okay, so you haven't tried it yet.
Not the laser head.
Yeah. Yeah, and I've seen that there's certain CNC machines where you could get lasers. They come with a laser as well, too. I saw there is, but they're not cheap.
Sorry, Peter. Question for Dave.
Yeah, the CNC machine I have, they do have a laser attachment for it, but I can't remember how much it is. I don't think it's that bad. I think it's like $100 or something, but I can't remember. And there's people out there that are using them, but I haven't really paid too much attention to it, mainly because I haven't figured out completely using the engraving bits, let alone now put a laser head on it. Maybe down the road, we'll see.
Yeah, because I thought about a CNC for PCBs, but the problem is if that PCB is warped, or it's got to be completely flat, because if you're scoring away copper, it may gouge too deep, or it may not gouge enough.
No,
there's
a mapping function on it, and you can tell how fine of a grid that you want on the board. Like for example, if you took a board like this size here, you can see all my mistakes. I mean, you could either do a grid of four, or you can make it 6 across and 6. You know what I mean? You can determine, and it'll come down, and the probe will measure every spot on that board that you want it to, and it adapts to it as it takes into account the different heights, and it works really, really well.
Yeah, the Ender 3's got they've got mods for auto leveling. So where it does the same thing, it goes around because the board's got to know what level is. So if the board's twisted, you got to go and tell it where the board is so that when it prints, it accommodates for those deviations, right? And so I've seen they've got mods now, auto leveling mods for the Ender 3, where it goes around, it probes, and it figures out where 0 is on the x-axis, right? On the z-axis, sorry. It knows where 0 is.
One of the very first things you do is you have your probe come down at the starting point, and it measures there at the starting point, and then you tell it. Then you set up the mapping routine, and then the mapping values is all relative to that very first starting probe part. It works well.
So what's your ETA on delivery, Dave?
I have to check Banggood. I don't know, a month? End of the month?
Mm-hmm. Okay. I see a mini buildathon in the works here.
I'll have mine build way before you even.
No.
You go and look at the box.
No. When you get yours, then we set up a build day. Seriously.
Eric, it basically takes 30 minutes to set up the Ender 3. It's just rails you're screwed together. The hardest part's figuring out the software, how the software works.
Yeah, well, I mean,
they said that's how long they said it would take to set up the engraving machine was the CNC was 30 minutes. Yeah.
My CNC was my CNC mill 1 or whatever was like a 2-hour build. Well, and 2 days later, I'm still futzing with it. So.
2 days, 2 years, you still haven't finished it.
Yeah, well, I gave up a year and 363 days ago. Put it back on the shelf where it still sits. So anyway. All right, fine. Be a hermit over in Paris. Trying to get you socialized, that's all. All right, that's good. Thank you for your musings there. So maybe we will spend the rest of the time here. It's approaching 9 o'clock, so we're getting kind of towards the time that we normally start to wrap things up. But let's maybe just go around and see what's on everybody's minds and tables and all that. I guess focusing mostly on ones that haven't spoken this evening, because we've gotten a good idea of what's been tickling their neurons lately. So Al, I've got you first on my clockwise rotation here. So tell us what's going on with you.
Boy, I don't have a heck of a lot to report. Work is a conflict of interest, don't you think?
Always.
Anyhow, I'm progressing along. I think I mentioned in the last meeting that I've been collecting all the parts for the latest QRP SWR meter that was featured in Scrap Magazine. So all the parts are in now. So now it's start to see what I can do. The PC board is probably going to be the next thing in the next week or two. Pretty fine traces, so I'm going to find out how good my process is. So that's basically it. Nothing else to report. So back to you.
Okay, Drew, what would you like to share with us this evening?
Well, that's interesting. I haven't had a chance to read it fully, but I joined and got the Sprott magazine. Thank you all for your suggestion on that. I'd never read such a thing before, and it's really quite engrossing. So I just joined last month, and they had the magazine to me very quickly. So that was one thing. Something else I'm doing. Well, 3D printing. These are Anderson power pole sockets that I'm putting into electrical boxes for use in the shack and on the boat to break out my power. I've been having a lot of trouble with just basic cigarette lighter connections. They're all, anything you buy anymore no longer has a strong enough spring to hold itself in place, and intermittent connections all over the place. So I'm converting everything over to Anderson power poles. And in support of that, my wife presented me with this thing, which is a lithium-ion soldering iron. I'd never seen one before. I didn't really think it was feasible. It works like a charm. Remarkably little, simple device, and has about a half an hour's worth of soldering in a completely portable lithium package.
Drew, does that have a screen on it?
No.
No. Okay, with the temperature readout? No. Okay.
No, not a thing. No, you have no idea what it's doing. It is not for fine work by any means. It has quite a coarse tip on it, but for those repairs and that sort of thing, for just wiring, remarkably handy thing to have around. So Canadian Tire's got them on sale. And so that's about all I've been doing.
Okay,
playing a lot of 10 meter and 12 meter FT8.
Well, perhaps if you'll share your STL files for your Anderson power pole, it's something that we can do as a test print on, when we get our Ender 3s assembled.
Well, I do have an Ender 3, and I started out with a Prusa clone a few years ago, and it's a very robust machine. The guy who built it was a machinist, and it did very, very well. But I wasn't aware of just how inaccurate it was in terms of its motion until I got this Ender 3 off someone who'd given up printing mask supports. And it's a very precise machine. This is the simplest one. This is not the Pro or anything like that. The one thing I did do was I bought a magnetic mat for it, a flexible mat, which I have found to be very useful. I print primarily PETG. I have printed PLA for quite a while, but I printed PETG for the last few months. And with the Ender 3, if you print PETG, it will adhere itself to the bed like you have never seen. It's almost impossible to get it off. So the two tricks for that, and since you're getting Ender 3s, one, if you can, Amazon has a flexible mat, comes with a magnetic thing. It just sits on top of the bed, and so you can remove it and bend the mat underneath the part and take it off. The other part is a quick spritz of Windex on the mat, and then wipe it off, let it dry for a second, and your part will adhere, but you can get it off. And that is my big tip for the day. Is I found this on a Reddit forum somewhere, and it was a complete gift.
And it works.
Oh yeah, I wrecked 3 mats printing PETG, trying to get stuff off of it. It was impossible.
And if memory serves, that is the kind of ideal material in a lot of ways, right?
Well, it's very robust. Yeah, I would say so. It prints. It's a little higher temperature, about the same temperature as ABS. I use the Cura software to do the work. When I download something from Thingiverse or whatever, or build one in Tinkercad, I put it in the Cura, and then Cura has a slicer, and you can select Ender 3 as one of its machines, and it sets up the parameters for you for both ABS, for PETG, and for PLA. And when it predetermines all the settings for you, I find it works very well with the Ender 3. So it's nice. The first time I did this, I was playing around with Pronterface, and there was a lot of different software packages to get something printed. And now with the Ender 3 and Cura, it's a much simpler process.
Do you do both things, the Windex and the flexible bed?
Yes, I do.
Right.
Oh yeah, I wiped out three of those beds that came with the Ender. I've learned my lesson.
All right. Well, yeah, we may be sending some questions your way as we go through the process. Since you were the ender through is already assembled, I guess when you.
Oh yeah, no, I bought it off a guy that had, I guess he was. I don't know if they were buying these machines for people to go and print the mask retainers. Those kind of long clips about this long you put in behind. There was a bunch of them around town printing these things a year and a half ago, and this thing was barely used. He printed off a few hundred of them, and that was all he wanted. So he just, threw it on Kijiji for not much money. Yeah, so I lucked out. But yes, it was It was already assembled. I don't think 2 hours is going to do it. That's my bet.
All right. Well, very good. All right, thanks for that. I do appreciate the input. Very timely. So good. Okay. We have Howard. You're next on my rotation here.
Oh, not much to report from me. No, haven't had time to do stuff.
Okay. All right. Fair enough. Sometimes, yeah, as I was mentioned earlier, right? Work gets in the way of the important stuff. So.
Well, I don't work, but just that time of year doing things.
Yeah. Okay, fair enough. Fair enough. So, what else do we have here? Wayne, got you next on the circuit here.
Okay. So I managed to finish getting my winter antenna up just today, but I haven't done too much other than that of late. I'm doing some club duties for the inbound QSL card duty for the last couple of weeks, just trying to clear it up for the winter. Actually, I have something, maybe I'll bring this in later. What I got here, I've been playing with it, it's a voltage standard. Kind of plays into Kevin's talk. What it does is it uses the 8584 chip, which is a chip that produces 2.5, 5, 7.5, and 10 volt output. And its claim is that it's both accurate and stable over time. So I've had a need for this thing because one of my meters, it is a unity meter, likes to go out of alignment on a regular basis. If the power goes, if the battery gets down too low, it goes out of alignment. To replace the battery, it's still out of alignment. So I have to kind of align it regularly. I do like the meter nonetheless. So I got this a while ago just to have something in the shack that I could use with all my meters to see if they're roughly, reading right. So, if we ever get for a calibration thing, I'll bring this with me. That's it.
So it's a fixed voltage. Is that what it put?
Yeah. Apparently, what this thing is really designed for is a voltage reference for things like ADCs and DACs and stuff like that. So wherever you need a voltage reference is in there. What this thing is doing is hold it down, powers it on, it turns on a light, which you can see. If you keep pressing the button, it's toggling through the different voltages, which are coming out of 2 pins at the top. So this particular configuration, you can find these on eBay. They come in different shapes and sizes using the same underlying reference. So this one here just toggles between the pins, I guess, on the chip and brings them out to the output. Another thing about it is they've kindly put some calibration information on the back of it, which is you'll never be able to see, but somebody's used an Agilent 6.5 digit multimeter to read out the voltages and scribble them down here. So it is very close to the actual values. It's like, I don't know, I'm making this out as being less than 1/10,000th off, according to Agilent. But the specs say it's closer to like tens 10 to 30 parts per million is what it says on the data sheet, I think. It's I don't know. It's probably not good for really. It's not good as a calibrator for good bench instruments, I would say, because they have too many digits on them and getting too close to what this thing can tolerate. But for the types of meters that I usually use for hobby use, this has got a lot more precision in it than the meters I'm using. So it's a very good source for that.
Yeah, well, it's a good thing to bring to our calibration get together that we're tentatively proposed. So, yeah, good. Okay, maybe you could post a link as well in the chat for that for those that are curious about it.
Sure.
Okay, thanks, Wayne. All right, skipping over Peter because we don't want to hear any more from him. Michael, what's on your bench?
Yeah, I've been haven't been doing a lot. I've been doing a lot of DXing stuff, but one of my plans is to get the band decoder from the FT1000MP to work with my antenna switch, so I don't have to switch antennas by hand. I've got an antenna switch box here that goes out to the tower, but I'm going to use the band decoder on the back of the radio to do that, and so I got to do that. And I've also borrowed an automatic antenna tuner that I'm going to try as well. I'm using a manual MFJ right now, but I've got it's a LGD LDG 1000 that I'm going to try putting in. Starting to think about what to do. I'm going to do a thing on Smith charts, so I'm trying to figure out how to do that. I was talking to Peter about that, and what I'm going to do is basically build what I do around what Al Woke's done for Smith charts. I'm going to use that and do a bit of fiddling around, maybe see if I can actually do something practical, building a filter and showing the Smith chart for it. Anyway, that's sort of where I'm going. And one other thing I have in the back of my mind is I have a WESD 51 solder station, but I bought the manual version of it, not the digital version, and the manual version died. There's something wrong with it. I think it might be the chip inside, so there's some way to look at that, I hope. Anyway, that's sort of not much really, not much doing very much at all actually right now. I'm doing some woodworking and stuff like that as well, so keeping out of trouble we're trying to. That's all for me.
Okay, great. Thank you, Michael. And Dwayne, what's new down in Georgia?
Okay, let's see. I updated my blog the other day with the BFO I'm building for the Pete Simple sideband transceiver, and like I say, I modified it or made external modules I can plug onto it, and I'm in the process of writing the software for making it a general function thing, RF voltmeter, scalar network analyzer, couple channel signal generator, and a couple other things like there. I might do a couple other modules later to make basic signal generator function to it. A couple comments on the 3D printers. I've used the completely flexible map, and I went away from them because if you print something large and flat, the magnetic field on those isn't strong enough, and the whole mat will kind of curl up on you. So I've gone to the basically metal ones. They've got a spring steel plate, and then the magnetic stuff up there, and it stays straight. And there's a couple of different versions of slicers that you can use with it. I use Cura most of the time. Sometimes I use Prusa slicer, and there's the Idea Maker. They're all pretty good. They're all just about the same. Some of them have different features than other ones. And for PETG, I usually use just a little, glue sticks that you can get rub them, and put that on there as kind of a release agent for the PETG. And if you got some other high temp stuff that doesn't stick real well to those plates, to the bed, just a regular glue stick does a pretty good job of giving good adhesion when you have stuff that seems to want to lift off. ABS kind of wants to do that, and some of the other materials that I've tried printing, I've had to add a little bit of glue stick or something like that to give a little bit more adhesion. And that's about it.
Muted there. All right. Thank you very much, Dwayne. Appreciate sharing that with us. And also down south, although not quite as far, Frank in Windsor. What's on your mind?
Hang on, we'll get the picture going here. Yeah. Okay, here we are. There's nothing really on the bench itself, but I did do a little bit of operating this last 3-4 weeks, I guess, and I brought out my QCX Plus CW rig, and I built this last winter while we're in isolation. It doesn't show up very good on there anyway. And I used it in the Airbnb that we had. I used it on CW, but I wanted to see what the bands were like. So I set it up for Whisper, and with my 5 watts, and I don't know if you can see my antenna around the top of the way up here. That's the antenna I'm using. It's just wrapped around the room here. They got strict restrictions, and hooked it up with 5 watts, and was amazed at what I was able to get reports from. England, France, Iceland, Canary Islands, that type of thing, plus a host of hams in the States and Canada, out as far as Alberta. So just indicated to me that hey, the bands are open, so let's get on the air and do some CW DXing. And that's about it for here. I hope to have something on the bench soon to play around with.
Frank, have you ever used a mag loop antenna?
I've never used it. Well, pardon me. I did use it years ago. I built one, and it was quite successful, except the one I built was very sensitive to your hand if you tried to move it or turn it or anything. I'm thinking about possibility of putting one up in the attic, but I'm not too sure. I got quite enough height there, and I'm wondering how they work in a horizontal position, whether that would be possible or not.
A mag loop?
Yeah.
Well, I have an AEA mag loop, and it doesn't care.
Oh.
I'm not convinced that polarization is that specific for these things. I'll tell you, they're extraordinarily sharp in their tuning. If you alter the frequency much at all, that's a real pain.
Yeah, yeah. But
if you're adept with
some of the ones I have now have remote tuning on them, so I'm thinking of mounting it horizontally with remote tuning.
I don't know much about the voltages that develop on those things, but I would be inclined to keep it away from combustible materials.
Well, as far as the RF goes, I don't operate more than 5 watts.
Ah, well, yes, I think perhaps you'll be fine.
Yeah. I'm a QRP guy.
Yeah, no, that's fair.
But thanks for the information there, Drew. Well, I think maybe I'll give it a try.
I've operated it in 2 different, with both so-called polarizations, and I couldn't tell the difference.
Oh.
Well, I think by the time the signals get so mixed up, propagation being what they are, I'm not sure it makes that much difference for the mag loops.
Okay. I figured when they were in a vertical position and then putting them on a rotor might be quite effective. Did you try that?
I have never tried that, no.
Okay.
It's an interesting point. I suppose it merits some more experimentation. I've never used it over a long period of time. It was testing it mostly.
Mm-hmm.
And on those days that I got it working successfully, which, as I say, the tuning was a little fine, it didn't matter whether it was horizontal or vertical.
Oh, good point. I'm getting pretty good success with even this loop antenna around the ceiling here.
Well, I keep hearing it referred to in discussions, when you're space limited, how good they are, as well as nulling out noise, right? So, yeah. Okay. All right. Well, thanks, Frank. And I think last on the round table here is Hassan. So, anything you'd like to share with us this evening?
Not much on the RF front. I did some work in the woodworking shop. I built a table saw sled. I built the equivalent of an Incra fence by using 2 threaded rods. So threaded rod with 16 threads per inch. If you put them together, you can actually snap it to a 1/16 of an inch precision. So that's what kind of took up most of my time. And yeah, so nothing on the RF side.
How's your clock?
I got it ready. I got it almost working. I think the weight was a bit too much, so I checked it up. It's ready to be reassembled, so I haven't done that yet. But it was working for up to a minute, and then it would just overflow, like run through. So yeah, it's almost there.
All right. Very good. So I guess maybe we'll circle back to our presenters if anyone wants to put up their hand with Peter, Kevin, and Dave to give us a little bit of a chat. If you had anything else you'd like to share with us.
Well, I'll just a quick update on my project. I'm not sure where I left off last time, but I'll just do a quick view of it. There it is there. And it's come to a standstill because I haven't quite worked out the fine enough details that I want to put a fresh PCB on the mill. But my last venture with it, I'm pretty close, so I should be able to get a board milled out. Oh, well, of course, I'm up to my neck in leaves in the backyard, so maybe another couple of weeks I'll probably get a board milled. In the meantime, quite some time ago, I had bought, like these little SMA cables, assemblies that come like these ones right here. They come pre-assembled. And I decided quite some time ago, I had bought a roll of that cable, and then I bought some crimp and solder type connectors. And I gave it a go, and it wasn't too successful, but I needed to have something for this project. So I went back to the solder type. And that's working out really well. So if you're looking at these kind of cable assemblies and you don't really want to spend the money on the pre-made ones, the soldering seems to work pretty well. There's enough space in the tip contact that you can do a light tinning of the conductor, the core conductor, and still insert it into that pin, and then reheat it, and then it solders in there. So put a little bit of shrink tubing over the end, and it looks as good as the pre-made ones. That's it for me, Eric. Thank you.
Excuse me a sec. You're just muting the dogs.
That's impossible.
I don't have anything to add other than had some family stuff the last couple of weeks. So anyway, so other than doing the presentation, that was it for me. But
yeah,
Dave.
Yeah, Dave.
Dave who?
No, I was on mute. I wanted to show you guys something I've been playing. I got this old laptop here. It's an old Dell laptop. It was running Windows XP. And so I decided to get rid of Windows XP. It can't run anything much. And I installed over the past week, I've installed about 4 or 5 versions of Linux on this Ubuntu, Mint. I even put Raspbian on here. It was just, I had to have Raspbian running. What a piece of garbage. But anyway, I finally found this version of Linux here. It's called Antix, ANTIX. And this thing will run on a IBM PC. It's supported. It's got all kinds of stuff in it. And it shows you in the little corner there how much, right up here, it shows you how much memory it's using, and it's nothing. It's using next to nothing. As soon as you load a browser, it jumps up. But this thing, if you've got any old hardware and you're trying to revive it, ANTIX Linux.
Is it Debian based?
Yeah, it's Debian based. But I'll warn you, from what I've seen, it's on the website. They claim it's anti-fascist. It's an anti-fascist version of Linux. So as soon as you start seeing that, it's like, it's like, okay, why are they saying that? They've got some kind of political agenda. Right? Well, I know that'll pique Eric. Eric's gonna go, woo!
I mean, I've already got stickers on my laptop that say "This machine kills fascists." So,
and apparently there's I saw a YouTube video where a review of it, and they were saying in some of the browsers you get in there, it's got some links which are, they said blow away the links. So I haven't seen anything. I haven't seen anything offensive on it, but I just loaded it 3 hours ago. But it's the first one out of the box. Wi-Fi works. Everything works. All the other Linux I put on, I had to play around, gotten drivers to get the Wi-Fi to work. This one out of the box, boom, everything works.
Interesting. The version history goes back to 2007, so it's been around,
Yeah.
13 years, 14 years.
Does it come with its own VPN?
What's that?
Does it come with its own VPN?
Well, you just use OpenVPN, right?
No, I just thought if it was an anti-fascist one, they would have their own flavor.
Oh, yeah. I don't know. I know. I got to try plugging in various things to see if it's plug and play.
Always good to have, you can keep old machines running almost indefinitely. It's like an old car, right? If you just keep, whatever. Well, obviously, whatever OS it came with, you could just leave that on it, but you're not going to get very far. So, Frank.
Yes, I just want to ask Dave how you spell the name of the Linux program.
ANTIX. Antix.
ANTIX.
Yeah.
Okay. I've got a couple old machines around here, so I might look it up.
Frank, I just put a link to the Wikipedia page on in the chat. So.
Yeah.
Thank you.
Yeah, I put it on, and so far, early days, but so far it looks okay. My old Dell laptop here, it looks as if it's alive again.
Okay. All right. Very good. I have one thing to share here, and if I can pull it up here, it was a recent podcast that I listened to. It's the Amp Hour Electronics podcast, with Dave Jones and Chris Gamble. But anyway, one of the recent one featured actually a fellow Canadian. I'm sure most of you guys are aware of this particular, I guess, YouTube channel, right? Electro Boom.
I didn't know he was Canadian.
Yeah, well, yeah. He went to SFU, and he's he was asked during the interview if he'd ever think of going back to Iran, and he's like, no, this is my home now, and there's a lot more opportunities. Although, interestingly, in the interview, he did state that electronic shops are plentiful. He comes to I guess Vancouver, and there's kind of like Toronto, one here, one there, going out of business, whatever. But he said back in his hometown in Iran, there was a whole street just filled with electronic vendors, all selling discrete components, and just to walk in, because I guess it's because they don't have the equivalent of DigiKey and Mouser and all that available to them. So that's by nature. But anyway, a good less than 1 hour article. The guy's pretty funny, and has a good sense of humor. He's not quite his character that he is in the video. I haven't watched many of them, but I know, Dave, you've talked about him before, and just whatever. One of his interesting stories was how he said he almost died during filming one of his videos. I think he had taken a transformer out of a microwave oven, and it was falling off of his workbench or whatever. So he moved to get away from it, but it fell into him instead. And he said it, took a few layers of vaporized a few layers of his skin. But luckily, he said he had such a rat shit assembly that he just had the leads resting on that. So as soon as the thing fell, it disconnected, but not in time for him to get a little, a few volts, going through his body. He said for the rest of the day, he just sort of took it off, sort of went and laid down somewhere. He said he had the oddest sensation, not just of the skin coming off, but all this sort of cold sensation that went over in waves over his head and his brain. So, anyway, but it's a good hour to waste, so you should check it out. I'll put a link in the chat box as well.
He teaches science in an odd way, in a very, he uses comedy, but you watch his channel and you watch an episode and you come away learning science, but you don't know it. The funny one is check out the one where he puts metal in a microwave. He goes, why can't we put metal in a microwave? And so he goes and he starts playing around with it, and he puts all kinds of metal in the microwave to try and make it blow up.
Yeah, I think one of his other popular videos, if not the most popular, is playing with an ESD gun, I think. Whatever. Anyway, I've got a few on my watch list now after listening to the interviews. So
he's got some. Like I said, he does science. He teaches you science in a very entertaining way.
Yeah. Yep. Well, the world needs more funny Iranians. So. Anyway,
home brewers might help too.
Yep. Okay, well, we're almost at the 2-hour mark here, so I think it's time to sign off and say goodnight. So unless anyone else has anything, we will see you all again, I think, is it Wednesday the 17th of November for our regular meeting. So thank you again for all of your input and participation tonight. And, what do we got there?
$73.
Yeah, 7-3, Frank. Boy, I still can't read that. Morse. Oh, yeah. Right. Oh, you're muted.
Thank goodness.
That's going to be your buildathon, Eric.
Our buildathon. Well, hey, if it's only going to take 30 minutes to put it together, then we have lots of time to do the Morse code tutor box, right? So.
Yeah, it's just doing it. It's just doing the Morse code.
Oh, that's the easy part.
I got to limber up my finger here. Is it a paddle or is it a straight key?
Nightmares when you wag your finger like that. So.
Yeah.
All right. Anyway, well, thanks all.
Night all.
Yeah.
Good night, everybody.
Okay.
Good
Bye.
Good night all.
Oh gosh.